On page 651, the last kind of question that has its own name. They are pi over 12 questions. Pi over 12 is 15 degrees. If you think of your pie plate, if we look at this nice one, do you notice that the spaces between 30 and 45 and 60 is 15 degrees? But the space between 0 and 30 is 30 degrees. There seems to be an angle missing. Well, now that we have our sum and difference identities, we can add all of those missing angles to our pie plate without the use of a calculator. So what we're sort of looking at is how many values can we figure out without our calculator? Yes. Yes, it would, like the 15 degree and the 75 degree families would be different because they have different reference angles. That being said, we're going to be able to figure them out in the same way. So for example, right, let's talk about 75 degrees. Let's go back to our formulas here at the beginning. If I have 75 degrees in sine, can you see that 75 degrees is 30 plus 45? And then if you write it as the right-hand side, you just have things that are on your unit circle that you already know and could figure out. So that is what we are going to do. For our pi over 12 questions. So if you want to find the exact value of cos of pi over 12 or sine of 75 degrees, our strategy is to use our sum and difference identities. Oh, yes, you are. We're going to use the families that we know, pi over 3, pi over 4, and pi over 6. They can all be written as something pi over 12. 4 pi over 12, 3 pi over 12, and 2 pi over 12. And if you can add and subtract those or any other family member to get the angle you want, then you'll be able to figure out an exact value for any pi over 12 family. That's from here all the way and hit those lockers without hitting a wall?
I mean, floor. Like you can bounce off a wall. But
Okay.
It's tough.
Only if there's like an obstacle or something. Like if you can do it exactly the same time as Mr. Braun is walking down the hallway or Mr. Peltier and still hit the wall. Definitely. So, looking at these three, can you find a way that you could add or subtract to get pi over 12? 4 pi over 12 minus 3 pi over 12. Perfect. Any other ways? 3 pi over 12 minus 2 pi over 12. So you could choose either one of those. It doesn't matter which one you choose. So if I chose 4 pi over 12 minus 3 pi over 12, this is my alpha, this is my beta. So I go to my formula, and I substitute those in. And of course, those are all on your unit circle. Yes? Yes. You are allowed to have an equal sign continue because it's a flowing equation. Plugging in your values, and you have to write your final answer as a single fraction. So how do you multiply fractions? Can you see the bottoms are all going to be 4s? You have a common denominator. So you can add the tops. And one thing you're going to find out about the pi over 12 family for sine and for cosine, whether it is the 75 degree 5 pi over 12 or the 15 degree pi over 12, you will always have a root 2, a root 6, and a 4. But sometimes the root 2 will be negative. Sometimes the root 6 will be negative. Sometimes both the root 2 and the root 6 will be negative. Sometimes they're both positive, like this one. So if you've done something with sine and cos and a pi over 12 family, and your final answer doesn't have a root 2, a root 6, and a 4, you've done something wrong. With the tan, you always get a bunch of root 3s. So here's our next one. Sine of 75 degrees, which is the same as sine of 5 pi over 12. We have to figure out in degrees, how could we get 75 degrees? 45 plus 30. Can you see any other ways you could get 75 with subtracting? 90 minus 15, but 15 isn't on our pi plate. How do you get it with subtracting? $150 minus 75, but 75 is not on your pi plate. 120 minus 45 would work, yes. But I would suggest finding the easiest one, 45 degrees plus 30 degrees. Plug it into your formula. Multiply it out, and what do you know? You get a root 6, a root 2, and a 4 again. This one, again, happens to all be positive. There's a lot more. We've got at least 25 minutes left, so that works out perfect, see. Next one we're going to do is we're going to find the exact value of cos of 17 pi over 12. But before we get into that, you always need to find two things from your unit circle, or anything that's coterminal with anything on your unit circle, that add or subtract to 17 pi over 12. So I'm going to give each of you a scrap piece of paper right now, and each of you have to find a different one. You're not allowed to find the same one as somebody else, so there's a little bit of a race, because if you think there are easier ones and harder ones, you want to find it quickly, because as soon as you find one, you're going to check with me if it works. If it works, I'll write it on the board. Something on your pi plate, like pi over 6 plus pi over 4. Does that add up to 17 pi over 12? No, it doesn't. But you need to find something that adds or subtracts to give you 17 pi over 12. Once you find one, you put up your hand. If it is correct, I will write it on the board, and that one is now taken off. Nobody else can get that one. So sometimes what happens is someone finds one that is three pi over 4 plus 2 pi over 3 is now taken off. Okay? You can find more if you like. Yeah, if you want to quickly find them all. And then the reason I get you to do this is by getting us to find a lot of them, we're going to notice a pattern that's going to help us find them quickly. And that's what I want to happen. Oh. He did too the first time. All right. So we've got 6 examples up there already. We could find more. What do you notice that all 6 of those have in common? Other than they all work out to 17 pi over 12. Hello, yes. Yeah, we're always using pi over 3, pi over 4, and pi over 6, but what do you notice in particular with those ones? There's always a pi over 4. Pi over 4 here. Pi over 4 here. Pi over 4 there. Pi over 4 there. Pi over 4. Tell me a pi over 4 we haven't used. We haven't used 3 pi over 4 with subtracting, right? Now 3 pi over 4 is what? Over 12. 9 pi over 12, right? So if we wanted to equal 17, we would need 26 pi over 12 to minus 9 pi over 12 to get 17. What does 26 pi over 12 reduce to? 13 pi over 6. 13 pi over 6 on our pi plate? Yes, it is. It's coterminal with pi over 6. So if you're trying to find something that works to be a pi over 12, you start with any pi over 4 that you want to, positive or negative. In fact, I would probably go about it maybe even like, if you started with pi over 4, that's 3 pi over 12. What would you have to add to get 17? You'd have to add 14 pi over 12. That's not hard to figure out. Now, when you reduce that, can you see, hey, you got that one. Without much effort at all.
Is 111 pi over 4 minus 79 pi over 3 work?
Most likely it would. If you wanted to start with 111 pi over 4 and figure out what that is, and then find out what you'd have to subtract, it will always reduce to things on your pi plate. Now, the reason it will always work gets back to the beginning here when I wrote that only pi over 4 is an odd number when it's over 12. Right? Other ones are 4 pi over 12 and 2 pi over 12, but only pi over 4 is an odd number, 3 pi over 12. And if you're adding or subtracting to get an odd number, you need at least one of them to be odd. So you have to use a pi over 4 family. You can't have 2 pi over 4s because odd plus odd is even. Okay? You can't have 2 even ones because you'll never get an even number. Someone says, well, what happens if I have an even number pi over 12, like 8 pi over 12? Well, then reduce it to 2 pi over 3, and it's back to your pi plate. Right? If you have an even number pi over 12, you can reduce it down, and you'll get to something else. So when we get to our question here, cos of 17 pi over 12, any one of those would work. You can start with any pi over 4 family. Right? I chose the 21 pi over 12 minus 4 pi over 12. I actually like to add more than I like to subtract usually, but so I choose a random pi over 4 that's close to 17. Then write them in lowest terms. Happens to be 7 pi over 4 minus pi over 3. Who found that one? That was the one you found right at the end, right? Yeah. That was the one you almost found, but you put a 4 instead of a 3. And now it's just back to a pi plate question. You have to be careful, though, because now sometimes they're in quadrants where things are negative. Now 7 pi over 4 is in quadrant 4, so cos is positive, but sine would be negative. And again, you get a root 2, a root 6, and a 4, but this time the root 6 is negative. on the final exam, sometimes they have a part B. And they said, you just figured out cos of 17 pi over 12. Part B, could you find secant of 17 pi over 12? And all you'd have to do for secant of 17 pi over 12 is flip your answer. There was a stretch of 8 years where there wasn't a single final exam without a pi over 12 question on it. Then they took it off for 1 year. And then it's sort of like, now it's sort of like every 4 or 5 exams they don't put a pi over 12 question on. But it's a pretty typical exam question. Well, no, during that 8 to 10 year stretch, 2 exams per year, it's like 20 exams in a row. Oh, like did they have one last time? Then for sure, I can check. Okay, here's an exam question where they tried to make it a little trickier. What did they do? They put a 4 in front. Well, that doesn't make it that much trickier. You still, here, ignore the 4 for a second. Right? If I ignore the 4 for a second, could I find cos of 11 pi over 12? Yes. Once you find it, it's going to be a root 6 root 2 all divided by 4. What's going to happen when you multiply by 4? The 4 on the bottom is going to cancel out. So this one answer is going to be a root 6 and a root 2, either minus root 6, minus root 2, or both positive, or one negative, one positive. Not sure. Okay? From your homework, you can do number 7. And you can work on that until 12:15.